Everyone? How's everyone doing? All right, that was like 27% of you. I came all the way from California, so it was a really long flight. How are you doing? There we go. Yes. Are we all excited to learn about how we, well, I was trying to have the title slide on there, how we go from zero to DevOps superhero, the container edition. So before we get started, I want to make sure that we set the expectations for what we can expect in the next 60 minutes. And by the way, my name is Jessica Dean. I'm a senior cloud advocate at Microsoft, and I have the best job in the world because this is what I get to do. I get to be an engineer and hang out with all of you. So for the next 60 minutes, we're going to go through a session that was designed to get you thinking, to get you excited, to show you what's possible, and then to give you resources where you can go and learn more. Unfortunately, I have not mastered osmosis, so I cannot make you an expert in the next 60 minutes, but I promise to show you some new things. Now, rather than making you wait until the end of the session, which I historically have done, and I know a lot of presenters have done, all the resources for every single thing you're going to see is in that QR code and that link, and it's live right now. Some topics covered in today's session is going to be a refresher of the basics. So if you already have experience in DevOps, in Azure DevOps, maybe in some Azure pipelines, or even Docker and Helm and Draft, we're going to cover some basics. So it might sound like a little bit of a refresher or a repeat, but I promise you it's necessary for the deep dive demo we're going to do. We're going to talk about Helm. We're going to deep dive into it. We're going to even make edits to some Helm charts. We're going to use Draft, which is a tool that's going to simplify our Helm and Kubernetes development experience. And then we're going to do some cool things with Azure DevOps, specifically Azure pipelines and Azure artifacts. So inside a Docker container, we're going to be able to deal with a Maven repository and push and pull to a Maven artifact repository feed that's living in Azure artifacts. Now, before we dive into the meat and potatoes and really kind of start talking, I want to go through a video that I believe really sets the stage for what DevOps is. And it really personifies a before and after of without DevOps and once you've embraced it. So let's take a look.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
Done. I love that video. And if you're familiar with Donovan Brown, who, by the way, is my boss, I work on a DevOps team. We call ourselves the League of Extraordinary Cloud DevOps Advocates. You may have already seen that video before. And I've seen it probably over 100 times. But every time I see something new, and it gets me every single time, there's a 62-second difference between the two videos. So it's obvious that once you adapt practices that help you embrace efficiency, you're able to move on with your day and increase your productivity. Now, one of the things I noticed for the first time in this video is the guy changing the tire in the old video, in the one from the 1950s, He changed the left tire up in the top corner twice. He put it on, he pulled it off. He wasn't quite sure. But in the second video, everyone had their job. You had 4 people to change tires, and you had redundancy built into the process. So in case something happened with one of those tires, there's another person right behind, like, okay, do you need me to go? I'm ready. I want to touch that tire too. I'm here. There's redundancy built into the process, and that's DevOps as well. There's so many practices we can take away from a video like this. One of the other things that I noticed is they clean the windshield 3 times. They're repeating efforts. They're doing things that are maybe heroic, having one person go around and change 4 tires. The entire premise of DevOps is to remove the heroic things that we do and do things in a way that makes sense and a way that's designed on a process. So that's what we're going to define. We want to make sure that we understand what DevOps is before I take anyone from zero to DevOps superhero. And by the way, I titled that session just that, because every single person in this room can do every single thing I'm going to show you in this demo. It's not exclusive to heroes. It's available to all of us. Now, if I were to ask 10 people in this room what DevOps is, I guarantee you I would get 10 different answers. Because some might say it's a job title, or maybe it's development and operations collaboration, or maybe it's automation, or it just means faster and safer releases. And the thing is, none of you are wrong. All of that is correct, but it's so much more. So to level set, I want to make sure we clarify Microsoft's definition of DevOps. And here's my favorite part, because the cameras always come out for Dono Dude and Donovan. But DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on that slide is value. If you're not delivering value, what are you doing and why are you doing it? And more importantly, do you know if you're delivering value? How can you tell? How can you gauge it? Do you have telemetry or metrics or monitoring in place that helps you assess your value delivery and helps you plan your next sprint, your next process? And do you have insight into that value, maybe in your containers, in your pods? Do you have any insight into what's running and where? That's going to be part of what we talk about today. Now, you might be wondering, why is DevOps actually important? Why do I care? Can't I just do this container thing on my own? Do I really have to do all this DevOps stuff? First off, if you haven't embraced DevOps, or you've still been on the fence, or you worry it's too expensive, you're already behind. And it's more expensive not to embrace it at this point, because your competition is already doing it. Embracing DevOps increases your velocity. It reduces your downtime, and it reduces human error, because you have a process and a plan and a set of practices in place. And by the way, this just isn't my opinion or what Jessica Dean thinks. This is based off of an actual study. There's actual research that goes into this. Every year, it's typically released around October, there's a State of DevOps report that's released to quantify in numbers how valuable DevOps is. You have a faster time to market. And these are statistics compared to lesser performing peers and companies that have not adopted DevOps. Those who have are able to increase their deployment efficiency by 46 times. They have a 7 times lower change failure rate, which results in increased revenue because you have over 2,500 times faster lead time for changes and over 2,600 times faster mean time to recover. So sometimes people hear, oh, I can automate because I can roll out, I can roll forward. But DevOps is also the ability to automate your fail. Fail fast, roll back, and quickly recover. And DevOps enables you to be able to do that. Now, DevOps is a 3-stage conversation. So you have people, you have process, and products. But it starts with people. It starts with every single person in this room. You are an engineer if you fall on the developer side, the operations side, the jack of all trades that just does whatever their boss tells them to do, which should be every single person in this room. And then we start with process and products. But we have to talk about the people first. Because previously, without DevOps, we had these silos. We had this wall of confusion in place. And I think we all know the developer mindset. Fix my code, finish everything, bundle it all up, commit, push, I'm done. Well, it works on my machine. It's your server's problem. It's not my fault. I have an idea. Just give me access to your server. I'll take my little zip disk over. I'll go ahead and pull down from some private FTP server. I got you. I'll fix it. But that doesn't work, because then the operations people have things that they have to worry about on the other side of the wall. With this wall in place, it leads to disaster. We need to remove the wall. Once we've done that, we go into our process. And this process and these words, this union of people, process, and products applies to everything, even beyond just containers. But you'll see how this really sets the stage for the container demo later today. We have to start with a plan. That's where we're going to really kind of maybe use boards or Kanban board, really have an idea of what we're going to fix in this sprint. Then we're going to do our develop and test. That's our build, our unit tests, our build verification. We'll move on into release, where we release it to our various environments, dev, test, QA, canary, prod. And then the monitor and learn, which is so important. That's the part where we're going to get our telemetry and metrics. That's the part where we're going to be able to see if we're delivering value, have some sort of logging in place, and reapply it to the next plan. So it continues working just like a well-oiled machine. And like I said, this really sets us up for the talk of containers, and we'll start to see why. So first, let's make sure we know what's a container. It's an application delivery mechanism. It's not a real thing. It's really just process isolation. So I have an encapsulated runtime that now I can put somewhere because it's immutable. If you come from the Windows world, it's based on several key Linux kernel features. So it might have words that you're not familiar with, namespaces. It's what a process can see. That's your mounts, your networks, your C groups. And a C group is what a process can use. That's your memory and your CPU. If you are already familiar with Kubernetes and Helm, maybe you've already edited resource requests and limits with your CPU and your memory. And that's where you're telling your process that you're running in this Kubernetes pod, in this container, how much of the C group that process can use. Let's also have a side-by-side on how containerization is different from virtualization. Virtualization, your hypervisor sits on top of bare metal or sits on top of an OS, but you still have to manage independently a virtual machine with a guest operating system, your library files, your application on top of it, your binaries, all independent runtime dependencies. And each VM can differ. But with a container, it's encapsulated, right? Now I have my entire runtime environment, all applications, all dependencies, sitting in a container that sits on top of a Docker engine, that sits on top of the host OS, that sits on top of the infrastructure. But that still doesn't make sure we fully understand what a container is. And this is very important because sometimes we forget how layers work. So in a container, you have the container layers that sit inside the image. Remember that that's built from a Docker file. Every line in the Docker file gets passed into a layer. The layers are read-only. So if I build anything in my Docker file, and I put a personal access token or a secure XML file or any kind of content that I care about the security, and I bake it into one of those read-only image layers, and I publish it and run it as a container, I can still access the read-only layers. So that means that I've just violated a security, maybe policy at my company, because now a personal access key is baked into the image read-only layers. The read-write actually happens on the container layer when you run it. So we want to remember this structure and utilize multi-stage builds, and we'll talk about that. Multi-stage Docker files. I can use whatever secure information I need as a builder, build my application file, my jar, my DLL, and then copy that over to a second stage, leaving the first build stage as an intermediate build image that just gets trashed. And I don't have to worry about caching secure information in a read-only layer. Now, the container advantage. Now, we've already talked about how it solves problems in general, but I want to make sure we fully identify how it solves problems for developers and IT. We talked about how there was this wall of confusion. There was this maybe divide in these silos. But containers really helps address a lot of those problems. For one, you have fast iteration now for the developer. You have an agile delivery system, and you have something that's immutable. So I don't have to worry about, it worked here, why doesn't it work there? And for IT, there's cost savings in place because I'm not managing several different machines and environments. I have an efficient deployment method because it's going to work the same in every stage. And I even have elastic bursting, where if I need to go into a different environment, a different cloud, maybe private or public, on-prem, I can do that very simply using containers. Now, we also want to make sure we fully understand what Kubernetes is. It's an open source container orchestrator, and it was designed to automate deployment, scaling, and management of applications. For any in the room that's new, that maybe doesn't know the history, it was originally invented by Google, and it was based on a system that they use called Borg to run billions of containers per week. There are currently over 2,300 contributors to the project, including Microsoft, and some features that Kubernetes offers is self-healing, automatic bin packing. Some of my favorites are load balancing, secret management, and automated rollbacks and rollouts. Remember, we talked about DevOps practices, the ability to roll out in an automated and seamless and streamlined fashion, but also fail fast and recover. And Kubernetes really gives us this. It's one of the reasons why it probably is so popular. It has DevOps practices baked right in. Some key Kubernetes objects that you may have heard or may be familiar with. You have replica set, stateful set, daemon set, service, ingress, namespace. All of these, while some might be more complicated and more robust than the other, at its core, they are all just objects, and they all get deployed the same way, in a Kubernetes manifest or deployment declarative syntax. And Kubernetes takes that syntax, and it works in what's called a reconciliation loop. You have your desired state, which is what I define. I define the object I want. I define all the fields for that object. And Kubernetes will sit here and say, OK, here's the actual state. Does it align with what you've asked for? I'm going to make sure that the way the world is the way you've told me to make it so. And Kubernetes will constantly work in this reconciliation loop. Here's an example of that declarative syntax. This example is deploying out a deployment object. You can see the top, I specify an API. I specify the kind of object. And then I fill in data that makes sense for that object. The last section down at the bottom is spec, where I start defining what I want for my container. Now, this is an Nginx container, which is just a public image on Docker Hub. But maybe I want my container to be a private image. Maybe I want it hosted somewhere other than Azure Container Registry. And ACR and AKS allows me to link through a service principal. But if I'm using my image and it's hosted in Quay or a private repository on Docker Hub or third party, I'm going to need to add in image pull secrets. And I can do that by simply just putting in the YAML block to make that work. Once I've deployed it, Kubernetes takes it and puts it out on the nodes as per my declarative syntax. And then we also have Draft and Helm. Helm is the de facto Kubernetes package manager, and it's powered by a template engine. It's inevitable that the deeper you go into containers and the deeper you go into Kubernetes, the more complex your workloads are going to become. You're going to have several objects that oftentimes will have the same field value, and you're going to have to make sure they're always in alignment. You're going to have to manage sometimes 5 or 6 different YAML files and make sure there isn't a tabs or spaces error or some other kind of error where your name for a metadata tag is off from a label on another object. Helm solves that problem because now I can manage all of my templates, maybe my deployment, my service, my ingress, maybe a config map. I can manage all of that through parameters I define in a values file. And the values file becomes my knobs and dials. But still, to get started and create a Helm chart is still sometimes scary. How do you know where to get started? There are tools like Azure Dev Spaces will help and Scaffold, but today we're going to talk about Draft, because Draft was specifically designed to complement Helm and to streamline your Kubernetes development. So you can think of it kind of like your release automation tool, especially from a development perspective, because it works on your local dev system. So using just 2 commands, I can get started and get a template for my Helm chart that I can use for my application. I can then get started with a Docker file, and I can make the adjustments per my application. It's automatically going to detect which language I'm writing in. So now, as much fun as it is to sit here and watch me show PowerPoint slides and talk with my hands, we're going to switch over to a demo. Before I do, you can go ahead and take a picture of this and scan those links. Don't worry, none of them work right now. We're going to make them work through this demo. We have a dev link, and we have a production link. I'm going to switch over to the demo now. Make sure I sign in here. And I have a code project. It's a Java application, has Maven dependencies. It's just a Spring Boot chat application. You can actually chat with people. And you'll notice that if I show you the actual contents of the repo, I don't have a pipelines YAML. I don't really have any kind of YAML aside from a Maven YAML. I don't have a Docker file, and I don't have charts files. But I want to take this project that's a public project, it's a real project, this isn't something that's hello world that I'm going to start from scratch, and I want to see if using Azure Pipelines we talked about, Azure Artifacts, which we'll dive deeper into, and using Docker, Draft, and Helm, if we can take this out into Kubernetes on Azure. So to do so, I'm not going to leave GitHub initially. I'm just going to go to the marketplace. I'm going to open this in a new tab. From there, the marketplace, which is a collection of tools that'll help me get started with my code, offers a category for continuous integration. I'll select continuous integration, and from there, I'm just going to find Azure Pipelines. Now, I already have it installed on my account, but if you don't, you just scroll down to the bottom here, and you can install for free. It's completely free to get started. If you have a public project, we'll give you 10 parallel builds, which for those who don't know, you can, sorry, my microphone keeps falling off. For those who don't know, you can actually have multiple jobs. So I can build maybe a Xamarin component, a Linux container, and a Windows app, all as part of one build, separated by different jobs. And if my project is public, I can do up to 10 of those jobs for free. I also get unlimited build minutes. For private projects, by the way, you still get 1 parallel job and 1,800 build minutes. Once you have it installed, you're going to want to configure access. Now, I just clicked Configure Access from that page, but the link that I'm at is really just my Settings tab. So when I go to GitHub Settings and I scroll over, it's just the Applications tab right down here at the bottom. Any application you install from the GitHub Marketplace will show up there. I'm going to go and configure, and it does make me choose a password or sign in with a password because I'm about to give it some permissions. I'm about to give it some authentication. The permissions I'm specifically giving is write access to code, read access to metadata, and read and write access to checks, commit statuses, deployments, issues, and pull requests. It's going to have access to anything in my repositories, in my GitHub, that I say I want to grant access to. I could give access unsolicited and unparalleled to all repositories, but that's a little too rich for my blood. I like having some security and control. So I'm going to only select certain repositories at the time that I want them to have it. So for now, I'm going to choose my Spring Boot application, and I'll simply hit Save. From there, it's going to take me over, and it's going to ask me to log in with a Microsoft account. I'm already authenticated in my browser, so I'll just select that account. From there, I'm handed over to Azure DevOps. So I could get started without ever actually leaving GitHub. And if I don't have an Azure DevOps account or organization, I could just create one. I could create a new project. Now, I do have an organization. I have about 17 of them, so I do not need an 18th. So I'm going to leave my organization. And I do have a base project that is just empty that we're going to want to fill. So I'll hit Continue. From there, it's going to go through and scan, OK, which repositories in GitHub do I have access to? Where does your code live for this project you want to start with? I'll choose my Spring Boot application. It'll validate permissions. And from there, I can configure my pipeline. It automatically scans the code and says, this looks like a Maven project. Would you like to start with a Maven project? Would you like to start with a Maven package and use a web app to Linux on Azure? Would you like a blank pipeline? Or my personal favorite, if some of those are wrong, I can choose quite a few more, including Go, Gradle, Node. You can keep going. The list seems like it never ends. One of the things I like is we even have Xamarin templates, Xcode templates. It's really, really rich. Now, we know that this is Maven, so I'm going to go ahead and choose Maven. Now, from here, this is just going to give me a really basic pipeline, right? I can see that. The trigger says master branch. The pool is just a hosted Linux agent. We'll talk about pools. And then the step is just a Maven task. Really, all Azure Pipelines is a task runner. You give it tasks, and it runs them. So I'm going to go ahead and leave this as the basics. We're going to want to make it a little bit more robust. But I'm just going to hit Save and Run. And since I'm new, and I want to kind of get started and go from zero, I'm not going to work directly off of the master branch. We're going to create a brand new branch, and I want to zoom in so you can see this. We're going to call this build 19. And not only will it create a branch, it's automatically going to open a pull request on this new branch into master. So it's going to do that for me without me having to worry about it. The second I hit Save and Run, this is automatically going out to the GitHub repository. This agreement is between Azure Pipelines and GitHub. Any other tools that I'm going to use, which I will use VS Code and Draft and Helm, all of those are outside of this agreement that we've just set up from the marketplace installation. So when I go back over to my GitHub, you can see the branch already got pushed. I can refresh the page real quick. We will go to that new branch. And when I scroll down, right here, we have an Azure Pipelines YAML, and it was added 24 seconds ago. So without me having to leave anything, Azure Pipelines took care of where I'm getting started. But you might be wondering, this is great, but that build isn't doing anything. I want it to actually do stuff. So we still have the old visual CI that makes it really easy to get started with tasks. So I have a pipeline that I already added in with tasks that make sense. We're going to take a look at some of the tasks. The first thing is you can see that I have my build pipeline, and I have an agent pool. And I told you we would talk about the agent pool. Right now, I'm using a private agent. We can see that. It's all the way down here at the bottom. I'm using a private agent that I set up, but we do have hosted agents. Because I'm working with a real-world project, I'm working with Maven packages, I'm working with a Docker file with layers that I care about, and I care about the timing of the build, I'm choosing a private agent. But I could easily switch this over to a Linux build agent, and it would work just the same. To set one up, it's also super simple. You simply go to Manage, which is right above that, and you could go to your agent pools, and from there you can add in new agents. It's just a script that you run. Once you have your pipeline set up, you choose your sources for where your code is, and then right here, this Kubernetes deployment is just a job. I could add another job, where I just say add agent job. You see that down here. I can go down here to add a task. Here's my little task runner. I select a task. We'll zoom out just a little and add that in, and the tasks start aligning. But since I've already created essentially a task pipeline that makes sense, we see that I have Docker build and push, I have install Helm, I have Helm package because I want to package up my tarball, I want to make sure that I version control it, I'm going to copy the Helm chart and the jar file as a build artifact, and I'm going to publish those artifacts so I can use them in release. But you'll notice something interesting. I have also a download secure file up at the top, and then a second step that's copying that secure file from a temp directory to my working directory. That secure file is the secure way I'm passing my settings XML for my Maven project, because my settings XML is something I created for my Maven artifact repo. And simply to connect to the feed, you hit connect to feed, you go to Maven, you generate your Maven credentials, which you paste into the server brackets of your settings XML. But it gives you an auth token. I can't just pass that in plain text or upload it or check it into source control. So instead, I've added it to my project as a secure project. From there, I also add my repository snippets to my POM file, repositories, and distribution management. So we'll go ahead and do that live. That allows me to have Azure artifacts that I can now pull. But I'm doing it in a Docker container, so we'll see how that's working. I had to copy it to the working directory because that's where the Docker context lives. And you can only have Docker look at the context, so it needs the settings file there. So to make sure I'm still being secure, my last step of my pipeline is to clean up the secure files and delete that settings file. So there isn't any kind of auth information ever left on the build server. So now to get this into YAML, I'm just going to select the job. I'm going to view YAML, and I'm going to copy it to the clipboard. From there, I'm going to open Visual Studio Code. I'm going to open the project that I have on GitHub. We're going to make this really big. I'm going to switch to the right branch, which is my build branch. Let that pull in. We'll zoom in just a little. And you can see, not my git ignore, you can see the Azure pipelines, which was the pipeline that we committed to GitHub. I'm going to delete this, and since I just copied the YAML that I want to my clipboard, I'm going to go ahead and paste that in. And just like that, it takes all the visual tasks and pastes it into YAML, including setting a trigger for the branches that I want to include. I only want this firing on this one branch. So I can save that. And that's great, but we do know one of the things I had to make a change for was my POM file. So I'm going to go right here to name a description. I'm going to tab in, and I'm going to add in those particular changes that I said we needed to update so that we can work with Azure artifacts within our project. So I have repositories, which is pointing to my dev Azure com JLD and Maven branch, and I put it in distribution management. Now, to do the whole walkthrough of this from scratch, there's already a YouTube video I made live earlier today. It takes a total of 5 minutes and 41 seconds, I believe. So that's also available in the links at the end. So I'm going to close this, and that's great. We know that we have our Java project done. But now we need Draft and Helm. Now we need the Kubernetes stuff. Here's where things get really cool. So I'm going to clear my terminal, and we'll make this just slightly bigger. You can see, when I zoom in, I'm using Docker for desktop. I have Kubernetes running in Docker on my Mac. So I'll simply do helm ls to see if I have any deployments, which I don't. I'll do k, which is my alias for kube control. I'll do k get pods. I don't have any pods. I'll do the same thing for services. And I do see I just have the standard Kubernetes service. I can interact with it the same way I would any other Kubernetes cluster. So I'm going to clear, and I also have Draft installed. So for Draft now, I'm going to go ahead and say draft create. That's going to automatically detect my language. It's going to detect my project, and it's going to give me several files that I'm going to need. You can see I have a charts directory, which we'll take a look at. But most importantly right now, it's going to give me this Docker file. So the first thing I notice with the Docker file is it's just very basic. But I can see that lines 1 through 4 is an as build stage. And then on 6, I have another from stage. This is where we're doing that multi-stage Docker file, and Draft gives it to me by default. So this means that I can securely start setting up my application and have the settings file get copied into the container and have Maven run the build and pull from Azure artifacts inside my container. And then it's going to produce a jar file that I'll ultimately copy right here on line 9 from the build stage. So we'll go ahead and add in the add settings. So right from my local directory, copy it over to the root directory of my container. Now there's a few more things I need to change. For one, I need to change the base image because I do want to have a fast performing and secure container. So I'm going to choose an Alpine-based image. I'm also going to update the environment port. My application serves on 8080, so I'm going to make that change. I know that I want the jar file. I don't have it output with dependencies. It's just going to be a jar file. So just find anything that's jar and go ahead and execute that. So the Docker file looks really good. But we need to worry about our charts directory. Because in charts, as we talked about templates, here's my deployment file. We talked about what a deployment file looks like. But you'll notice on line 9 now, for replicas, rather than being hard-coded, it's saying go look at .values.replica count. Build ID is .values. In fact, if I select values, you'll notice how many times values is being referenced in this template. And that's because we actually have a values YAML that's going to be managing everything in our deployment, our ingress, and our service. So I just go to my values YAML, and now I can control all the variables and all the parameters that exist in all my templates in one place. So I'm going to update the internal port of the application to align with 8080. I'm also going to change the resource request and limits. So instead of having 100, I know my application needs more. Remember we talked about C groups and being able to view and have access to hardware for processes. So I'm going to change this to 256, and then I'm going to change the memory to 512, because I know my application is a little bit more robust. Now from there, that looks good from just a basic. So we'll go ahead and say draft up. Now what this is going to do is it's going to build the Docker container locally. It's going to push it into a local repository, and it's actually going to run it in my local Kubernetes cluster so I can test it out before I check it in and make it run in Kubernetes on Azure. But to make it run in Kubernetes on Azure, I need to start setting up the charts and the templates that they gave me with a little bit more code. For one, we talked about private repositories. I'm not going to have my image in a public repository, so I need to add in some image pull secrets. So I've already created a secret on my cluster, and I'm just going to give it the name. The name of the secret I created was build 19. Now I'm also going to update the ingress. So I don't like using load balancers, and I'll talk about this at the end. I'll use load balancers to initially ingest traffic, but then I'll take advantage of application routing or Nginx to actually proxy my traffic to different services. And you can see how I have ingress, I have a host name, I have annotations. I even have a cluster issuer where it's going to automatically issue an SSL TLS certificate. And I've even enabled TLS. But anything that you define in values, is only as good as what actually exists in the templates. So you need to go over and make sure that whatever you're referencing also exists in your template files. So for one, we need to make sure that we have an image pull secrets YAML section. So when we take a look at it, if you have image pull secrets and values, please add this YAML. Remember, everything in these declarative syntax is what Kubernetes is going to go off and do in the reconciliation loop. So we'll go ahead, zoom out, and we'll save that. It was really the only deployment change we made. The second change we made was our ingress. So we can see our ingress is really very basic, right? We have our kind of object ingress. We have metadata, but there's no information for annotations. There's no information for TLS. There's really not much here. So we're going to go ahead and clear this, and I'm going to paste in a little bit more robust text. We're going to have in ingress if it's enabled. Also, if we have annotations, handle the indent. Put the annotations in place so that I can say I want to use HTTP application routing or Nginx or whatever additional adapters I want to use. I also define the spec a little bit further, specifically with sections 19 through 24. If I've enabled TLS, create the secret for me. I'm auto-provisioning quite a few objects, and we'll see this at the end. So I'm going to zoom out. I'm going to save this. I can see my local deployment has completed. So we'll go ahead and bring this up. We'll zoom in here. We'll drop down. And the first thing I'm going to do is helm ls again. You can see I now have a deployment that was just deployed. We'll go ahead and do k-get pods. And I now have a pod that's running. I'll do k-get services. And I now have a service that's also running. So just like that, I was able to deploy. Now I can even do some cool things like k-logs Spring Boot, and that's the name of the pod. I use tab for autocomplete, and I'll hit enter. And I can actually see the logs in real time because I'm just connecting to Kubernetes how I normally would. And just how I normally would, I could use kube control, port forward over to a deployment, and actually connect to the deployment itself. But draft makes this even simpler. Instead, I could just use draft connect, and it's going to connect over to the application running in the pod. I can see the logs in real time, so I can actually see that Tomcat started and my WebSocket demo is running. And we'll scroll up just a little to grab this localhost IP. I'll go over to my browser. I'm going to open it in a new tab. And I can see the application running locally on my system. So this tells me I'm safe to go. I'm going to go ahead and check in my modifications. So I'll see draft helm, we'll commit, and we'll push. And because of that integration between Azure pipelines and GitHub, and because I already opened a pull request and had the continuous integration trigger added, that Azure pipelines that I updated before I messed with Docker or Draft or Helm, it's already fired off a build. So this pipeline that we were able to export from the Visual CI is already off and running over in our builds. So we'll go over to builds. We'll leave this page. You can see Draft and Helm is already up and running. In fact, if I go to GitHub and I go to my pull request, I can even see that there's a build in progress. I can drill down into the pull request, and I even see that it's added the latest commit automatically to that pull request. I can see the build verification information from the completed one, and I even see a pending one for the one that's in queue. When I go into the pending one, I can see the details. This is this rich integration here, and I can even view the details of that original build on Azure pipelines. Now we can go back to builds right now and see how our draft Helm is done. It's completed really quickly. In fact, it's only taken 31 seconds. When I did this the first few times, it took on average between 5 to 6 minutes. And the reason why it went so fast was because it was able to cache layers, because I'm using my hosted agent. Now, we'll show you in Maven, I can't show you necessarily that I was able to build and pull all the artifacts, because it already cached those in a layer, and I haven't changed that. But you can notice, I haven't refreshed the page yet, here's my Maven artifacts. And right now, one of these artifacts has 219 pulls. I have insights into this information because of artifacts. So we'll go ahead and refresh. And now I should have, scrolling down, finding the 200, Looks like I still have 219 and 74. But you can see when you drill down into each one of the informations, you can see each individual package, feed, connection, and you get really rich information that can give you insight into your builds, which again helps you with that insight into delivering value. Once your package has built and pushed, you can go over and release it. And just like in build, it's going to take you over to the release stage, where you can actually choose a template. This time, we're going to go ahead and choose Helm. So I'm going to deploy using Helm. I'll choose this to dev. You can choose any other template as well. And I'm going to go into the tasks. The first thing I'm going to do is select an Azure subscription. So I already have one that's selected. I could choose a new subscription, and I could authorize it. Or I could granulate out the security with advanced options. I can use managed identity. I can scope it even further to a management group or even a resource group. So I can get really granular with my security. In this instance, I'm just going to do a service connection I've already authorized. I'm going to find the resource group of my actual cluster where it lives. And I'm going to go ahead and find the cluster itself. Now, the second I select it as part of the process, you'll notice the other tasks have already populated that information. So one thing I need to edit in my Helm init task is to turn off wait, and I'm going to make this be client only, because I don't really need it to deal with tiller or anything. I already have that configured on my cluster. The last thing I need to do is do the actual install. And I'm using Helm upgrade install so that I set this up to always be upgradable and iterative. So I'm going to choose this to go to a namespace. This is a best practice, and we'll talk about this at the end. I'm going to choose a chart path. And the chart path is the linked artifacts that I published over from my build stage. So I'll drop this down, I go to charts, and I'll find my tarball. From there, I'm going to also name the release, and we'll make it match the space, the namespace. So from there, we have namespace, release name. The last thing we have to do is values. So we already defined a lot of our values if we go and look at it, but we didn't do much with image. So if we look at our deployment, we can see exactly what's needed to be defined in our values. Our deployment is expecting values.image repository and values.image tag. But I didn't put it in my values YAML because I actually want to override that as part of my pipeline. I want to override that at deployment time. Maybe I want different environments. Maybe I want different container registries or different clouds. I can set this up at release time. So I'm going to go ahead and use image repository, still the same structure, of my Azure Container Registry. And then the build tag is a predefined variable for the build ID from the previous build. Now, this is cool, but it's still not really full scope. So we're going to go ahead and clone this, and we're going to make a second stage called prod. And it's super easy to get a second stage because the clone already took all the information from the other one. But I do need to update my Helm upgrade task and put my prod containers and pods in a different namespace. I'll name it something different. And the values I also need to update. The values needs to also have a different ingress host name because I don't want to use the same host name for dev and for prod. So we'll leave that. I'm going to go back over to pipeline. And now I also want to set some post-deployment conditions and some pre-deployment conditions. And it might not be a big deal in a two-environment scenario, but when you are working with dev, QA, prod, canary, you have all these different environments. Your developers might say, this looks good, I've validated everything, this deployment is good to go, but QA might not be quite ready for it. They might still be working on something else. So you let the environment who owns it control what flows in and what flows out. You can also set approval policies. The user requesting a release or deployment should not approve it. You could revalidate the identity, and you can even skip the approval. So we'll go ahead and close out of this. We'll save, and we'll let it release. So I'll create the release, hit create, and this is going to take it all the way out into Kubernetes on Azure. You can even watch as it queues. So I'm going to go to my big terminal here, and I'm still using Docker for desktop. I'm going to change to a cluster I have on Azure. Now, this bottom half of the screen is actually doing a watch command on the build 19 dev space. So the second we get down here at the bottom to the Helm upgrade task, you'll be able to see a pod actually create, and you'll see the deployment happen. And then just like how I tested everything locally in draft, I could run commands to see the logs, to see the services. I could see all the objects that were created, everything that got bundled up and packaged in the Helm chart that we made changes to for our actual Kubernetes deployment. So you can see the container creating, and it's already running. So I'll do the same Helm ls. I can see now that I have quite a few different deployments, obviously, particularly because this is a cluster that I use. But you can see build 19, you see the revision, and the namespace and date is today's namespace and right now. I can go and do get services. I have to make sure I specify the right namespace. I see the service. I'll do the same thing with ingress. And there's my ingress. We'll copy that URL. And I also want to see, remember we talked about secrets and certificates. So let's go ahead and get certificates. I can see the certificates that were created. Now let's go look at the logs. Logs -n build 19. And hit enter, and I can see the logs that are running. I see that it looks like it's starting Tomcat, WebSocket, it's still firing up. As soon as this is fired up, and I can do a watch command or just keep refreshing this, we can be able to go and load the page in our browser. And the picture you took earlier of our dev and of our prod QR codes, we'll be able to actually see that application live in real time. So let's do the logs again. We should be ready to go. So we'll go over here, paste this in. And just like that, I do want to zoom in here so you can see, it is certificate. It's a valid Let's Encrypt certificate that was issued by my Kubernetes cluster. There's a video about how to configure that, also included in the resources. But all of that was deployed by our pipeline. In fact, if you went to the website before the demo and saw that it didn't work, you could go to it now, and it is live. I'm not going to leave it on the screen, but we'll go ahead and sign in, say start chatting, and everything's working. So now I can go back over to my pipeline, and I'll go ahead and approve this because this looks good to me. So I'll approve. We go back over here to release, and I can see that just because I approved the development stage, it still isn't automatically flowing because I was able to really kind of set those limits. I can also do cool things with gates where I can automate that and maybe have it ping a website or make sure that it doesn't have a certain amount of browser alerts and have the gates automatically check before I let it flow. But we'll go ahead and have this flow automatically into prod and let that deployment happen. Now, I'm sure what's on everyone's mind is, this is cool. I already knew a lot of this, or maybe some of it's new, but Donovan Brown announced unified pipelines. So aren't you going to show me something about that? The answer is yes. So I'm going to switch over now to a project that I created, and you can see it's called E2 Build 2019 for end-to-end. So right now, if I go to pipelines, it's going to look the exact same as what my other project looks like. That's because I don't have the feature enabled. So I'm going to go to the top right corner. I'm going to go to Preview Features. And I'm just going to scroll down. And the feature I'm looking for is multi-stage pages for pipelines. Once you turn this on, not only will I get a different interface for what my pipelines looks like, but then I'll also get a different experience for building my pipelines. So rather than starting out with having my Maven code and my Maven YAML of just here's one task and you can't choose anything else, I now get what Donovan showed, where I can actually choose tasks and add them in, and it'll give me the YAML. I don't have to go back and forth. I can also drill down into a pipeline that I created, which, by the way, is this same exact demo. So you can, and this is available on GitHub. I'm going to show you what it looks like after. But you can use it today. It still works. It works with this particular code base, and it'll work with the same exact cluster that I just deployed to. You can drill down into your stages. So you can see my build stage, I have my deploy to dev stage, and I have my deploy to prod stage. When I go into the build stage, I can take a look at Docker build and push, can zoom into the logs, and we'll scroll down. And you'll notice right here, starting on line 20, I'm downloading from dev, Azure, Com, JLD, and Maven. This is where you can see in real time how it was downloading from Azure artifacts. Now, I'm sure you're wondering how the actual deployment to dev and prod looks like, what it looks like. Here's the actual. It's on an A2, AZ2E branch on the GitHub link that you have access to. You can see the trigger. You can see the variables. This is starting to look the same like what we structured for our getting started demo. But now we're starting to see how we still have tasks, but those tasks live under stages and jobs. So I have a build stage, and I have a job for build. Then I put my steps and my tasks. The tasks are the same. We have download, we have copy files, we have the Docker build and push, which now I can do, by the way, as one task. I have Helm package. I scroll down even further, and here's my next stage for my deployment stage. It depends on my build stage. If I didn't put build, or if I put build for the prod stage, I'd have two of them that would both depend on the same stage. You could stagger it however you want. Based on condition, make sure that it's exceeded. Here's my deployment job. Here's my pool. Environment is really neat. We'll show environment, because now I could deploy to multiple environments and multiple endpoints. Maybe it's multiple clouds in different namespaces. I have, again, the same kind of tasks that we talked about. It needs to get the artifacts. It needs to make sure that Helm's installed on a system. It needs to do Helm init to get the authentication to Kubernetes. And then it's going to run Helm upgrade. And all of this just works once you set up the stages and the jobs. So we'll go take a look at pipelines. I want to drill back up to the top, and I want to show you those environments. So you can see here that I have a build dev environment, and I have a resource. I also have a prod environment. When I drill down into the resource, and I zoom out, you can see the actual workloads. I can zoom in, I can see the services. I can see if I had a load balancer or external IP. I can drill down into the workloads and see that the pod is running. I can drill into the pod. I can keep going deeper and deeper. But here's probably one of the coolest things that I think is not only can I get an overview, but remember, I had to keep running manual commands in Draft and in Kubernetes to see the logs, to see what's going on in my container. Now, right from Azure Pipelines, I have the logs right here. I can see immediately insight into the container and see what's happening. I can also go over to the YAML, and I can see the YAML that was deployed through the Helm chart that we created. The exact same way that I went through to create this demo is the exact same thing I did step by step in the first part of this session. If I scroll all the way down, we're going to even find image pull secrets right here on line 67 and 68, which was the image pull secrets that I added to that Helm chart. And so it really helps you have that full traceability and insight into what's running, where, and when. And now, as awesome as some of all this is, if you're still looking from going from absolute zero to have something in full, we have one more thing. You may have heard of it. It's called the Azure DevOps project. But I want to show you one key thing that's really cool in what happens with that project. First, to get started, you simply go to add a new resource in the Azure portal, and you locate the DevOps project. From there, you can start with an application. You can choose .NET, Node, Python. We have quite a few. You can even bring your own code, which I think is pretty cool. I'm going to choose .NET, and next, you're going to choose your framework. And so I'm going to choose .NET Core. It's a little bit more comfortable for me with containers. It's a little bit more fun to work with, I think. So I'm going to choose Next. And from there, you can choose the service you want. So this is really helpful if you don't have a Kubernetes cluster, or if you do, you can use it with both. If you want to get started with Service Fabric, Windows Web App, Linux Web App, or one of my personal favorites down at the bottom, you can even go back in time to the year 2001 and deploy to a virtual machine. So I'm going to leave it at Kubernetes service. I'm going to hit Next. We'll zoom out. And from there, I just fill in normal data. I give it a project name. I give it an Azure DevOps organization. If you don't have one, you can create one. You can give it a subscription that you want. You give it a cluster name. Or under additional settings, it'll actually open a side blade where it gives you the option of create a new organization. Here's your service group. You can choose the type of Kubernetes version you want deployed. We support up to 113.5 right now. You can tell it how many nodes you want. By default, we're going to give you 3. If you want log analytics enabled, HTTP application routing can be automatically enabled. That's Microsoft's version of Nginx. If you want to create the container registry and what name you want, you can do a lot of really powerful things. And then you hit Done. This is going to build your entire pipeline. It's going to build all your infrastructure, all your architecture, and it's going to give you sample code. It takes about 15 minutes, and unfortunately, that's just too long to wait for architecture and infrastructure. So I already have one that I created for you. Once it's done, you get a dashboard that looks like this. It'll give you a CI/CD pipeline. It gives you access over into the code. Like I said, we give you sample code. I want to show you the sample code because especially if you're looking to get started with containers and insights and Kubernetes and Helm, we give you sample charts. So when you drill into the charts, you'll notice we still looks the same kind of structure that draft gave you. But one thing that's really cool, when you go into the values file, you can scroll down and find, right down here on lines 56 and 57, something that says Application Insights. So we talked about how to edit values files and how to edit your Helm charts. Anything that exists in values has to go exist in a template. So we go over to our template, we go over to our deployment, and I'm going to scroll down just a little bit. We know that it's listening to a container, so I'm going to go to our container spec. And right under here, environment variables is where I'm assigning the Application Insights instrumentation key. Now, I can use this as a template or an example and update any of my own Helm charts to have the same kind of key. And all I need is an Application Insights resource. I can create that manually. But now I kind of start understanding how this stuff all fits together. I also can go over and see my build CI. So that gives me some insight into, again, the same exact kind of visual that I showed you and walked through, minus the secure files. And I get the same thing for CD. I get that external endpoint that I told you about. If I zoom in here, you can see that I'm using a really long, robust name that's impossible to say. It's because it's using application routing zone. And I can even tie application routing zones back over to something called Azure Front Door, where I can do load balancers for microservices. This project gives me a lot of landing and foundation to really get started into a much bigger world than just setting up pipelines and just playing with Kubernetes. It really helps me set up my microservice future. So I'm going to go back over, and the last thing, because we've talked about value a lot, is the value of seeing what's running in your container. Unified pipelines allows me to see the logs. It gives me insight into what's happening in the container. But application insights working inside your pod gives me the same application insights I'm already accustomed to getting in web apps. I can set alerts, I can set dashboards, I can adjust my Azure DevOps dashboards to showcase the information that helps my team figure out if we're delivering value. So it really kind of comes full circle. I'm going to switch back over to PowerPoint here. And our demo part is done, but I just want to recap. We had code living on GitHub. We used Azure DevOps to handle our entire Kubernetes pipeline. We had Docker build and push our image, but we also had it work with Azure artifacts in a very secure way. We were able to structure our pipeline securely and our Docker build securely. We were able to package our Helm chart and push that over to our next release stage. We can also push that, by the way, over to Azure Container Registry, because you can have your own private Helm chart repository in ACR. And then we ultimately took everything, bundled it up, and deployed it out to Kubernetes on Azure. We did it to a dev stage and a prod stage. And by the way, the time for that entire demo is just over 31 minutes. So you really can get started very simply. Just a few more things I'd like to recap. Some best practices that we talked about very subtly, but I want to make sure we review. First off, the importance of building small containers. Right? We switched, one of the first things we did with Draft was we switched the based image to an Alpine-based image. The footprint is significantly smaller than a Debian-based image. In fact, I took a really popular project that's Python-based called Home Assistant, and I noticed that their Docker file was 2.2 gigabytes. I'm like, ouch, this really hurts. I wonder if I could make it smaller. Does anyone want to take a guess how small I made it? Shout out a number. Huh? 500 megabytes. Yeah, it was about a third of that. I got it down to 120 megabytes by using Alpine, base images, and multi-stage Docker builds. Also consider your application architecture. Use namespaces to allocate your resources. Use Helm charts. It will help you with your objects. Consider RBAC, role-based access control. It's already enabled on your cluster. Don't just create service accounts and give God-like privileges to every single service. Give it to what needs it and only that. And then implement health checks. We didn't talk about this too much, but definitely implement health probes that helps tell you if your application is actually up and running, not just if your pod is running. That's important. And then two more, set resource requests and limits. We talked about that. If you have a memory leak, make sure the scheduler will kill it, because this is using too many resources. Go ahead and restart the pod. And then be mindful of your services. Map external services. You don't have to do everything in Kubernetes. You can utilize external databases and external storage. In fact, I usually recommend it because they're globally redundant. They have additional scale. They were specifically designed to handle those kinds of tasks. Don't rely on load balancers. They're expensive, for one, both from a cost perspective and from a time management perspective. Take advantage of application routing and load balancing and services that are built right into Kubernetes. And then finally, if you want to learn just a little bit more about the end-to-end pipeline, unified pipelines experience with Kubernetes, Atul Malavaya, Sean McKenna, and John Stalo are going to be in this room tomorrow at 12:30, and they're going to dive even deeper on end-to-end application development and DevOps on Kubernetes, Azure Kubernetes Service. So I'll let everyone grab a picture of that. And then finally, if you missed the slide, all of my build material, everything is right up here, aka.ms/jldean/build19. Thank you, everyone, for hanging out. You can now go get food and, I'm assuming, drinks.